Welcome back to Ox Tools. I'm Tom. So tonight we got kind of a weird one. I would call it a homeowner's machining job, or this is what happens when a machinist bumps into a homeowner job. So the other night our washing machine started leaking. It had been weeping a little bit before, but we didn't notice it. We just thought it was humidity or something like that on the concrete. But what's happened is there's you have the rotating drum in the washing machine, and a drive shaft projects up into the drum, and there's a couple of seals down at the bottom of the drum. Excuse me. Anyway. One or both of those seals started leaking. So I finally diagnosed it and figured out where it was. And the power of the internet works. I plugged my model number in, and I got the Maytag parts, online parts, and I was able to locate a seal repair kit and get it ordered. So it's on its way here. But I got to disassemble the thing to get at this thing, and it's got a castellated nut that holds the whole mess together. So I've got that exposed, and I'll shoot a little video in there in the laundry room where the thing is, and you get to see that nut. And I tried, I just gave it a try with a spanner wrench, a hook spanner like this, and I wasn't able to knock it loose. So I put a little. It's an aluminum nut, okay, so it's or zinc nut, and it's probably dissimilar metals together, and it's been in there for I don't know how many years, long time. So it's probably a little bit corroded, and it's got everything bad going for it. And many years ago we did a lot of work with washing machines, and we made a similar tool for disassembling the washing machines. It was for a consumer product research project, and we had to disassemble the washing machines and do some things to them. So we made a tool very similar to this for almost the same purpose, different model washer. So I'm kind of familiar with how the things go together. So anyway, so we're going to make another one of those tools. It's kind of pertinent. It really ends up looking like this right here on the end of this. This is kind of what it looks like, except it's a larger version of that. And I know Don Cossett up in Oregon's working on one of these for his milling machine, so he'll probably get a kick out of this video and cutting these teeth. Although these teeth are simpler to cut than these. The ones I need for the washer are straight. These are tapered here. Anyway, so we have some indexing, which we've been talking about, and a little bit of tool making here. And then I have to have a drive system so I can hook it to an impact wrench so I can take my washing machine apart. Anyway, we'll go in there and we'll look at the nut, and I'm going to scrounge around the shop for some tube and some materials, see what I got, and we'll make us a tool, and cross our fingers that that corroded nut we'll be able to get it off. So anyway, this ought to be interesting. This will be a little longer one. I won't be able to do this in 15 minutes. So anyway, stay tuned. Okay, so here's our problem. That castellated nut down there, and excuse my bouncy video here, we have to unscrew that to replace a seal underneath that, and then this seal here that's on this spline shaft. So we'll take some measurements, and then we're going to make a socket. Okay, so I took some measurements and I made up a little chicken sketch here. So this is the castellated nut. So we have to make a kind of a spanner driver that fits down over the shaft that's sticking up and engages these slots here. So I went scrounging around in the material bin here, and these are some leftover chunks from something else. This is 8620. In fact, this was left over from making those press pins a while back. So this will actually work pretty good for the tooth part, and then this will be my clearance that drops down over the shaft. So what I'm going to do is, first thing I'll do is I'll just kind of put these together and weld them together a little bit, and then I'll get this in the lathe and do a little boring and a little turning on that to get it close to what I need. So let's get cracked. Let's go over to the lathe and fire it up and get going. All right, first step here is this diameter is actually real close to fitting in there. In fact, it probably will, but there's a little bit of this knurl left over that's flared the end out. So I think what I want to do is just turn that a little bit so that it fits that, and then I can put those together and weld them. So we're just going to pop this in the chuck this way here. I'm using my my cool double boost light here. All right, let me get some measuring gear. All right, let's see where we are back here. 1 inch 991, and then the it's got a little burr in it. This is just a triangular scraper here. Let's get a measurement on that. Well, that's 1 inch 998, so those should actually go together if I get rid of that little raised lip on there. In fact, maybe we'll just bust it off of there with a chamfer. Let's see what happens. Do a little adjust in there. Alright, ready to go? Yep. Yeah, you can hear the knurl coming off of there. Alright. Let's see. Oh, look at that. Just like it was made for it. Okay, so let's go weld that. Alright. Get a little weld on there. I'll just get a couple tacks. I'll hold this down. It's not going to need a lot of weld, so okay, that should be plenty. That should be plenty for what we're doing with this thing. All right, let's, ooh, that's kind of warm. piece is still kind of warm there. Let's see, there's no reason to choke up on it too far. All right, let's do a little turning. I don't remember what this diameter was. 2.804. I want 2 3/4. So I got 50 thousandths, a little over a millimeter. Just clipped. I was wondering what that noise was, and it's touching the areas that got welded there, so that material hardened up a little bit right there. You can see, so this is 8620, this is a reminder, and we welded it here, and you see how it's shinier there than the rest of the material? So what that means is that little area got a little harder during the welding. So let's see that. I wonder if that's showing up in the video. Anyway, this area right near the weld's a little shinier, which is an indication that it's a little bit harder there. Okay, so see what we got. 2" 764, so 15 thousandths. Hear that? That's it hitting those hard spots. It's no big deal, but just interesting. Alright, let's just break these edges a little so I don't kill myself on them. And you could hear it on that too. It squeaked a little bit. Okay, so see if I did what I thought I was going to do. Yep, we're good. Okay, now we're going to pop some holes in that. we got a 1/2 inch pilot hole through that. Now we're going to switch to an 1.5 inch drill to rip out some more material. Change speeds here. So that's, we're going to go down to, okay, yes, 200 RPM. And, this is like a 40 millimeter drill. Big guy. Should add a little bit. See what the speed looks like. Okay, that'll work. One holy. All right. Let's get a boring bar set up and then we'll do a little boring. Okay, let's go here. So that little mark, I just heard it go through the back side of that, so I'm just putting a little witness mark on there so I know when I'm getting close. Okay, it feels pretty good. We got a ways to go yet. So we're running 550 RPM, and the feed rate is about 8 thousandths per rev, which is I don't know, 0.2 millimeter per rev, something like that, 0.2 of a millimeter per rev. So actually, another thing is, you're probably wondering what's my depth of cut. I'm not really looking at the dial. I know I just got to get a bunch out of there. So it's probably, I try to do more than the nose radius of the insert. So I bury the nose of the insert. So in this case, I'm probably taking a millimeter and a half on the diameter, something like that, 60 thousandths per pass. Let's see what we got now. Okay, so I'm getting close now. So I'll take a lighter pass. Okay. So the front part of this gets bored out. It gets a big counter bore, 2.3 inches, 60 millimeters, something like that. So this is roughed now. I'm going to rough the counter bore now. So I'll come up and zero my tool because I know how deep I want it to be. I'm zeroing my travel dial, and then I'll come in here and I'll take some passes down to 1 inch. Okay. So that's roughed. This thing's pretty hot right now, so let's get a little measurement here. So we want 2.3 and we're 2.29, about 2.289, and so we're pretty close on that. So I'm gonna let it cool off a little bit, and then we'll do a finish pass on that. And the other hole, I'll reach in there with something else and measure it, and we'll probably take one more pass on that too. That's just a clearance diameter there, so scale dimension, you know, 6-inch scale dimension is fine for that. But we'll go ahead and measure it, so just so we know where it is. So that's pretty toasty right now. Yeah, and you can see it's steaming there. So we'll let that cool off a little bit. That way I can touch it, and then we'll finish it up. All right, so we'll do some finish cuts here. I'm going to slow the feed rate way down so we get it nice and smooth. We'll come back and recalibrate on that surface. Alright, and I just need 10 thousandths on that one. And then on this other one, we're just going to use an old school tool here because it can reach in there. And like I said, it's just a scale dimension, so we don't really care too much about it. But, you know, we like to know what it is. So I'm just feeling it in there, and okay. And then, you gonna be able to see this here? So I just put my scale against some reference surface like this, and then look at it. And I'm looking at the scale here, and I got about, I don't know, 15 thousandths left, something like that. So we're just going to take 15 out of that little inner bore in there and call it good. I can see. Touched off. Pretty good. In fact, if I can get it out of there, there's a little sliver of material that's the piece that was left over, the part that I stuck in the bore. It's kind of loose in there now, but not that loose apparently. Huh. So I got this loose ring in there now. I'm trying to get out. maybe I'll just leave it. Oh, there it goes. So that was the piece that I stuck in the bore there, the little counter bore. So it's matching up with the bore pretty good right now. All right. We're going to break a couple edges there, and then we're going to go over to the mill. Okay, so we're on the mill here, and I went ahead and, you guys have seen this before, so I just went ahead and put that, my V-block rear jaw in, and then we're going to put this in here like so. What I want is I want to put a little parallel under here so that I keep an accurate position there. And that is what we're going to do right there. Now that's sticking up a little high, but we're not doing heavy-duty cutting up there, so we should be fine. I'm not going to worry about it too much for what this tool is for. So let me lock that in there. Feels pretty solid to me. And then we'll get centered up here. Do the eyeball centric first. Take a look at it, both directions nicely, and then we'll see how far off we are. Yep. All right, that's pretty close. So let me re-zero. One more time. Yeah, close enough for what we're doing. Okay. Now this is kind of what we're cutting right there. This kind of castellations on top, and you know, sometimes you get lucky. The Maytag folks, they put it's 8 castellations, so they're 45 degrees apart, which is a nice easy index. So you know, we don't have any kind of weird numbers or anything to work with. So we're gonna cut this away, and we're gonna cut down about a ½ inch, you know, 12 millimeters down, and leave a tooth. So first we'll do here and here, and then we'll do here and here, like so, and then we're going to rotate it 45 degrees, and then we'll do that and that, and then we'll do that and that, and we're just going to cut away this material like that, and chop it out of there, and then that's pretty much the toothed end, and we can go try it on the washer nut. Okay, so we'll come over here. We're on center right now. I'm going to touch off on that surface, zero my quill, and then so the tooth that we're leaving is 3/8 of an inch wide, about 10 millimeters, and this is a 10 millimeter end mill here. So we're just going to shift off the diameter of the end mill, which will leave 3/16 plus 3/16, and see how that looks. Yeah, looks about right. And I'm gonna go a little more. Let's try 400. Yeah, it looks like it'll be all right. All right, so let's do a cut, see what happens here. So, what do I want to do? And I think I'll just do one tooth at a time instead of going all the way across. Check the teeth depth on the nut. I don't think I need to go quite as deep as I thought originally. Yeah, I went and measured it again, and I was right. I don't need to go. I don't need to go ½ inch. I can go 3/8, about 10 millimeters deep, and I'll be fine. I'm finishing the side of the tooth now. All right. $400. All right, let me get my calipers. Looks pretty good. That was just to the numbers there. Yeah, 376, so we're within a mil, 25 microns. All right, so I got a bunch more to do, and then I'll be sure to show the index when I index this for the 45, because that'll be interesting. Okay, so I'll do a bunch more, and then I'll come back for the index.